Now, one example to show how you can find if at a point the curve is maximum, at a point if the curve is minimum, or if it is a stationary point, if it is a point of inflection. So as per our flow chart, if you remember, you always first let us read the question. You are given this curve equation, and it is mentioned that find the stationary points. The moment you read this one, you find what is dy by dx. And when you write dy by dx is equal to 0, this is already 1 mark for you. Trust me, the moment you read stationary point, and if you write dy by dx is equal to 0, that would be 1 mark already. And now we will find dy by dx, which is 15 x power 4 minus 15 x square. This is dy by dx. We said that is equal to 0. And you try to find the values of x. So you factor out 15x square. When you factor out 15x square, you have x square minus 1 is equal to 0. Don't do one silly mistake here. Don't just say that you divide by this one. So what you should do is you would say 15x square is equal to 0, or x square minus 1 is equal to 0. So product of these is 0, meaning either this one should be 0 or the second one is 0. So from this you can say x equal to 0. From this x square is equal to 1, and then x would be either plus 1 or x would be minus 1. I would write all these values here. I have x equal to 0 or x is equal to 1, x equal to minus 1. We know that these are stationary points, but we don't know if it is a maximum point or minimum point. To find maximum or minimum, so we have dy by dx already. We have dy by dx is equal to 15x power 4 minus 15x square. We find d square y by dx square, which is 60x cube minus 30x. This is d square y by dx square. So we use this one at every place and see if there is a maximum, minimum, or a point of inflection. So we have d square y by dx square. You do d square y by dx square at x equal to 0. So at x equal to 0, this bar tells you at x equal to 0. If you don't write also, that is fine. So at x equal to 0, this is also 0. We already discussed that this would be point of inflection. This is point of inflection. And in order to find, see the point of inflection, the curve, if it is a point of inflection, it could be either like this, or it could be like this. So in order to know what kind of point of inflection it is, in order to know the shape of the curve, we go for a point. So we said at x equal to 0, we will find a smaller value which is closer to 0, smaller than x, and a bit bigger than x. I'll go with 0.1 minus 0.1. If you replace negative 0.1, again we replace in d square y by dx square. If you replace in this one, it is 60 times negative 0.1 cube minus 30 times negative 0.1 minus 30 times negative 0.1. So this tells you that, for example, this you can put it in the calculator. It is clearly this value is bigger than this one. It would be greater than 0. So before d square y by dx square, it is greater than 0, meaning concaving upward. Concaving upward. That itself tells us that the graph is going to be like this. The graph is going to be like this, but still we find at x equal to 0.1. So 60 times 0.1 whole cube minus 30 times 0.1. You can see that this is a bigger value, which is less than 0. So you know the curve before 0, at 0 it is stationary, before 0 it is concaving upwards, after 0 it is concaving downwards. Okay, so remember this line. If it is concaving upwards, this curve should be able to hold the line. If it is concaving downwards, it cannot hold the line. It may fall down. Yeah. So this tells us the shape. Now we go to the second part at x equal to 1. Remember, we are using only d square y by dx square at every stage. So you do d square y by dx square when x equals to 1. When x equals to 1, you find that 60 minus 30, which is 60 minus 30, which is 30, which is greater than 0. The moment you know that it is greater than 0, so you know this is a stationary point. The next point is greater than 0. The next gradient of next point is greater than 0. So it is a minimum point at x equal to 1. And at x equal to -1, again you find d square y by dx square, which gives me -30 at x equal to -1. You substitute that, and which gives us -30, that is less than 0. After this one, next point gradient is less than 0, so it is a minimum point. Now we have to find the y value at every place. So when x equal to 0, we go for as we are drawing the curve for the actual curve, you replace x equal to 0, then y would be -2. Now the point is 0 comma. Now the point is 0 comma -2. Similarly, when x equals to 1, you find when x equals to 1, 3 you replace here x equal to 1. So it becomes 3 minus 5 minus 2, which is -4. Y is -4. So you write the point 0, 1 comma -4, which is a minimum point. When x is -1, again, you can use calculator. Y would be equal to -3, +5, and -2, which is 0. The point here is -1 comma 0. Now you go and draw the graph here. So I'll use this space to draw the graph. So coordinate axis. The first point 0 comma -2, which is x is 0, y -2. We know this is point of the shape would be like this. And then when 1 and -4, when x is 1 and y is -4, this is 1 comma -4, this is 0 comma -2. This is a minimum point. And then -1 comma 0, here -1 comma 0, which has to be a what did I say? This is maximum, isn't it? Sorry. So this has to be maximum point. So you know now you would draw the curve. Now I would draw the curve. You know that at -1 comma 0, the shape would be like this. Shape would be like this. And at 0 comma -2, we know shape should be like this. So it should be like this. And then at this point, we know that this is minimum point at 1 comma -4. This should go like this.